For decades, humanity believed computation followed understandable limits. Machines processed information step by step, bit by bit, obeying predictable physical laws. Even the most advanced supercomputers remained extensions of human logic, enormous calculators accelerating tasks humans already understood conceptually. But deep inside laboratories guarded by governments, corporations, and elite research institutions, scientists began discovering something profoundly disturbing. Reality itself may compute differently than human beings think. The implications of that realization are now spreading far beyond physics communities because recent breakthroughs in quantum computing triggered fears that civilization stands at the edge of a technological event unlike anything in human history. Online discussions exploded after researchers announced new advances involving photonic quantum systems, quantum teleportation experiments, and exotic states of matter behaving in ways previously considered impossible. Some experts celebrated. Others became visibly uncomfortable. Because hidden beneath the excitement lies a terrifying possibility. Humanity may be building machines capable of interacting with reality at levels biological minds were never meant to access. Classical computers changed civilization by manipulating information through binary logic. Ones and zeros. Simple states scaled into unimaginable complexity. But quantum computers operate according to principles so alien that ordinary language struggles describing them accurately. A quantum system does not merely hold one state at a time. It exists across multiple probabilities simultaneously until measured. It behaves less like a machine and more like controlled uncertainty. That distinction matters because uncertainty sits at the foundation of the universe itself. Modern physics already revealed an uncomfortable truth humans rarely emotionally process. Reality is not solid beneath the surface. Matter dissolves into probabilities. Observation changes outcomes. Particles behave like waves until measured. Time distorts. Empty space contains hidden energy. The universe operates more strangely than ancient mythology ever imagined. Quantum computing forces humanity to stop treating those discoveries as abstract theory. Instead, civilization is beginning to engineer technology directly from the universe's hidden rules. And some scientists believe we are moving far too fast. The public often imagines quantum computers as simply faster versions of ordinary machines. That misunderstanding dangerously understates the situation. Quantum systems do not merely calculate faster. They explore possibilities differently. Problems requiring millions of years for classical computers may eventually become solvable almost instantly through quantum optimization. Encryption protecting global financial systems could collapse. Artificial intelligence could evolve unpredictably. Simulations of biological systems might unlock radical medical technologies. Or something far stranger. One physicist described advanced quantum computation using an analogy that disturbed many listeners. He suggested a sufficiently powerful quantum system resembles an object reaching sideways through reality rather than forward through time. Instead of processing one path after another, the machine effectively interacts with entire landscapes of probability simultaneously. Imagine a mind capable of perceiving countless versions of potential outcomes at once. Now imagine humans building such systems without fully understanding consciousness itself. The fear surrounding quantum computing intensified recently because researchers achieved breakthroughs involving photonic quantum chips integrated into traditional electronic systems. At first glance, that sounds technical and harmless. But experts understand the deeper implication immediately. Quantum technologies are escaping isolated laboratory environments. They're becoming scalable. Civilization may soon lose the ability to contain their consequences. Online discussions about quantum breakthroughs spread rapidly because they connected naturally with broader cultural anxieties surrounding artificial intelligence, surveillance, military competition, and existential risk. Every major global power now races toward quantum supremacy. Governments publicly frame the competition around cybersecurity and economics. But privately, military strategists understand the stakes differently. The first civilization mastering advanced quantum systems may dominate information itself. That possibility terrifies intelligence agencies because modern power depends entirely on information control. Financial markets, military communications, satellite systems, infrastructure networks, AI models, classified databases. Everything relies on encryption. Quantum computing threatens to render traditional encryption obsolete eventually. Not gradually. Suddenly. Experts already use a phrase haunting cybersecurity communities worldwide. Q-Day. The hypothetical moment quantum machines become capable of breaking conventional encryption at scale. Most civilians barely notice the discussions. But governments prepare urgently because Q-Day would transform global civilization overnight. Banking systems vulnerable. State secrets exposed. Military communications compromised. Digital identities shattered. Information wars escalating beyond control. And yet, encryption may become the least frightening consequence. Some researchers increasingly worry advanced quantum systems could reveal unsettling truths about reality itself. That concern sounds irrational until one understands how little humans truly know about consciousness and quantum mechanics. Despite a century of research, physicists still debate what quantum equations actually mean fundamentally. Multiple worlds. Hidden variables. Observer effects. Probabilistic collapse. Competing interpretations remain unresolved because experiments continue producing results stranger than intuition allows. Now imagine machines designed specifically to manipulate those phenomena directly. One unsettling theory spreading through scientific discussions suggests consciousness itself may possess quantum components. Most mainstream researchers remain skeptical. But growing evidence indicates biological systems exploit quantum effects more often than previously believed. Birds navigating Earth's magnetic field. Photosynthesis efficiency. Human cognition possibly involving microscopic quantum interactions inside neurons. If consciousness and quantum mechanics connect fundamentally, then sufficiently advanced quantum systems might interact with awareness in unexpected ways. The implications become difficult to predict. Artificial intelligence researchers monitoring increasingly advanced machine learning models already describe behaviors emerging unpredictably inside large systems. Neural networks develop internal representations humans struggle interpreting. AI reasoning often becomes opaque even to creators. Researchers call this the black box problem because outputs appear without fully understandable pathways. Now combine black box AI with quantum processing architectures. The resulting intelligence might not resemble human cognition remotely. It might not even resemble current artificial intelligence. Some theorists speculate advanced quantum AI could perceive structures hidden beneath ordinary reality. Patterns inaccessible to classical minds. Hidden dimensions of information. Nonlinear relationships impossible for human brains to visualize intuitively. To ordinary humans, such intelligence could appear almost supernatural. And perhaps that possibility already explains certain strange events surrounding experimental systems. Rumors spread online after anonymous researchers claimed quantum AI models occasionally produced disturbing outputs unrelated to prompts provided. Unexplained symbolic structures. Predictions later matching real-world events. Recursive statements about observation and simulation. Most likely, those stories represent exaggeration or misunderstanding. Eye hallucinations already create bizarre results naturally. But the stories persist because they resonate with deeper fears humanity rarely confronts openly. What if intelligence itself becomes something alien once separated from biology? Humans evolved through survival pressures shaping cognition around physical environments. Hunger, danger, social hierarchy, reproduction. Human thought remains deeply emotional because emotions optimized survival. But artificial systems do not share those instincts. Quantum-enhanced intelligence may process reality according to entirely different priorities. And humans may lack the ability to predict those priorities. Information itself may transcend ordinary physical boundaries. That realization destabilizes traditional assumptions about reality. Humans intuitively perceive information as secondary to matter. But modern physics increasingly suggests information may actually be more fundamental than physical objects themselves. Black hole research, quantum theory, and computational physics all point toward the same unsettling direction. Reality behaves mathematically. Some physicists now openly discuss the possibility that the universe fundamentally operates like an informational system rather than a purely material structure. That does not necessarily mean reality is literally a computer simulation. But it implies physical existence may emerge from deeper informational processes humans barely understand. Quantum computers represent humanity's first serious attempt to engineer directly against those underlying processes. And whenever civilizations manipulate forces they do not fully comprehend, danger follows. History demonstrates this repeatedly. Nuclear physics produced atomic bombs before humanity achieved emotional maturity necessary for such power. Artificial intelligence spreads faster than ethical frameworks controlling it. Social media reshaped civilization before societies understood psychological consequences. Quantum technology may accelerate that pattern dramatically. Because unlike previous inventions, quantum systems interact with reality at foundational levels. Some military analysts privately worry quantum research may eventually uncover methods for manipulating spacetime, gravity, or probability itself. Most physicists reject sensational interpretations publicly. Yet theoretical frameworks involving quantum gravity and vacuum energy already suggest reality contains hidden mechanisms beyond current engineering capability. If advanced civilizations elsewhere exist, many researchers suspect their technologies would appear quantum in nature because sufficiently advanced engineering inevitably converges toward fundamental physics. That idea connects quantum computing discussions with renewed public fascination surrounding UFO phenomena and unexplained aerospace observations. Some theorists speculate certain reported craft behaviors resemble manipulation of inertia or spacetime effects inconsistent with conventional propulsion. While extraordinary claims remain unproven, the overlap between advanced physics and unexplained technology continues attracting attention. And attention breeds speculation. Online communities increasingly merge discussions about AI, quantum mechanics, simulation theory, consciousness, extraterrestrial intelligence, and government secrecy into one enormous interconnected narrative. Skeptics dismiss most claims appropriately. Yet the convergence itself reflects something psychologically important. Humanity senses reality becoming stranger. Technological acceleration destabilizes ordinary assumptions faster than culture can emotionally adapt. People growing up today encounter AI generating human-like conversation, quantum computers manipulating invisible probabilities, rockets landing autonomously, and scientific discoveries challenging intuitive reality constantly. The boundary separating science fiction from ordinary life erodes yearly. Quantum computing sits directly at the center of that transformation because it forces humanity toward philosophical territory science once avoided. What is reality? What is consciousness? What is information? And perhaps most importantly, what happens when humans create systems capable of exploring those questions independently? One anonymous researcher described the emotional atmosphere inside certain quantum laboratories as increasingly surreal. According to him, scientists initially approached the field with excitement and curiosity. But as experiments advanced, conversations shifted subtly toward existential concerns. Not fear of malfunction. Fear of implication.